Welcome to lecture series on design and analysis of algorithms. In today's lecture series, we are going to see minimum spanning tree under greedy technique. So before we go on to the topic, let me give a quick overview on what dynamic programming is about and what greedy technique is all about. So the major difference between divide and conquer and dynamic programming is that divide and conquer can be applied to solve subproblems that are not overlapping, whereas dynamic programming is used to solve the subproblems that are overlapping. So the best example for non-overlapping subproblem is binary search, and best example for overlapping subproblem is finding Fibonacci series. So when it comes to finding an optimal solution, we always prefer dynamic programming approach. However, greedy technique aims at maximizing the result or minimizing the result. So if you want to maximize something or if you want to minimize something, we solve that particular problem using greedy approach. So here, in case of minimum spanning tree, you are going to find the spanning tree that is going to have the minimum cost. So this is a minimization problem. So this is solved using greedy technique. So these are the topics that we are going to discuss now. So initially, let me explain what is a minimum spanning tree. Then I'll give you an example of what spanning tree is about, what is a spanning tree. And we will see the different types of algorithms used for finding minimum spanning tree. And we will also see the difference between a spanning tree and a minimum spanning tree and its application. So look at this real life example. So this picture depicts about or it speaks about laying telephone wires. Assume you have a central office. From that central office, you want to establish telephone connection to all the other households. So you will establish the telephone connection in such a way that the total length of wire connecting the customers is minimized, or the total cost involved, total cost incurred is minimized. So now you can see both the figures. You can see two figures. The difference between the two figures is the first one is a naive approach and second one is a better approach. So that we are going to see today. So in that naive approach, from the central office to all the customers, you will establish a separate telephone network line. So that is what by default we used to follow. This is highly expensive. When you look at the second figure, so from the central office, so the number of individual connection from the central office to the customers is minimized here. So this is a better option, right? Better approach. So this minimizes the total length of the wire connecting the customers. So a spanning tree is nothing but a graph. Instead of telling like a graph, I can say like a spanning tree is a connected undirected graph. So a spanning tree of a graph is a subgraph that is a tree and joined all the vertices. So the major difference between a spanning tree and a graph is that spanning tree is also a graph. However, in case of graph, we used to have cycles. There may be cycles, but in case of a spanning tree, absolutely there will not be any cycles. So all the vertices in a spanning tree are connected with minimum number of edges. Here are some of the properties of spanning tree. So for a given graph, we may have more than one spanning tree. It is not mandatory for a given graph, we will have only one spanning tree. So for more than one spanning tree is permitted for a given graph. And each spanning tree of graph is a minimum. That is, it has a minimum number of edges connecting the vertices. So if an edge has a distinct weight, then there will be only one spanning tree possible for that particular graph. If all the edges in the particular graph has a distinct weight, then there is only one possible spanning tree that can be constructed for a given graph. So a connected graph G can have more than one spanning trees. So the trees does not contain cycle. So as the name indicates, spanning tree also do not have any cycles. It has n minus 1 edges, where n is the number of vertices. So in the spanning tree that is constructed, when there are 5 vertices, you will have 4 edges. But in a graph, you may have more than 5 edges also. Here are some of the real-time examples of spanning tree. So if you want to find the maximum bottleneck path, you can go for spanning tree and LDPC code for error correction, image registration with any entropy, identifying the salient features of face verification in real time, reducing the data storage in amino acid and proteins, auto-config protocol for Ethernet bridging to avoid cycles in a network. All these can be solved with the help of spanning trees. So, what difference between a spanning tree and a minimum spanning tree? So, as I have said earlier, a given graph can have more than one spanning tree, right? So, of all the spanning tree that we have constructed, the one with the minimum total cost is called as a minimum spanning tree. That means for a given graph, you might have constructed more than one spanning trees. So you have to sum up the weight of all the edges of a given spanning tree. So let us assume we have 5 spanning trees constructed for a given graph. So let me say first graph has total edge cost is 12, and second graph has 15, third one has 13, fourth one has 18, fifth one has 11. Of these 5, which one is minimum? Obviously fifth one, because it has the minimum total cost, which is 11. So this particular spanning tree is called as minimum spanning tree. So for a given graph, you can have many number of spanning trees. It's not n number. You can have many number of spanning trees, but a given graph, only one minimum spanning tree is possible. So thanks for watching. In the next lecture video, I'll give some example for spanning tree and minimum spanning tree, and I will also explain about the algorithms used for constructing minimum spanning tree. Thanks for watching.